so section 6.5 is trapezoids and kites. So a trapezoid is, by definition, a quadrilateral with exactly one pair of opposite sides are parallel. So exactly one pair of opposite sides are parallel. Okay, so we're not going to have more than one pair. We're not going to have both pairs. That would be a parallelogram, right? So we just have one pair of opposite sides are parallel. And our parallel sides we call the bases, and the non-parallel sides are called the legs. So don't let that confuse you when, like, you could have a trapezoid on its side, like something like this. These two are parallel. These would be the bases. This would be a base, and this would be a base. And these other sides would be legs. Okay, so bases don't have to be on the top and the bottom of the shape. Okay, so if a trapezoid is isosceles, then each pair of base angles is what? So do you guys remember isosceles triangles? So imagine extending this so that it was a triangle. If I had these sides were congruent to each other, couldn't I say those angles are congruent? It's the same idea for a trapezoid. So if we have two sides are congruent, these two legs are congruent, then these angles also have to be congruent. So then each pair of base angles is congruent. So it's not only that one, it's also these two. Those are also base angles. So if a trapezoid has a pair of congruent base angles, so if I knew that this pair was congruent, then I could say, oh, these two sides are congruent. Then it's an isosceles trapezoid. So an isosceles trapezoid has those legs congruent to each other. And then a trapezoid is isosceles if and only if its diagonals are. So what do you think about these diagonals? So this one, and if I drew it in differently, this one. What do you think is true about these diagonals? So this diagonal and this diagonal. They're congruent, yeah. And I could have you guys carefully sketch that out and maybe cut it out. You know, cut out two trapezoids that were exactly the same. You'd see those diagonals are the same, okay? All right, so what are the two shapes, I guess, that have congruent, actually there's three. So can you give me three shapes that have congruent diagonals? This could be a good test question. Three shapes that have congruent diagonals. What did we say in the last section? A rectangle. So a specific type of trapezoid, though. What kind of trapezoid? Isosceles trapezoid. What's the last one? A square. Yeah, so a square. Good. All right, so find the angle measures of A, B, C, D. So basically, whenever we have this trapezoid, if we extended our parallel lines, you would see that we have all of these angles that we learned from our parallel lines cut by transversal. So if we have 132 right here, 132 is also going to be right there. So what are we going to have for these angles? So if I have 132 here, what is this angle down here going to be? Yeah, it has to add to be 180, so it's going to be 48. Are you guys getting good at doing this in your head now? Subtracting from 180, subtracting from 90. You do it a lot in geometry. All right, so how about these other ones? Well, this is going to also be parallel lines cut by transversal. So what do we think for angle B? It has to be 90. Yeah, exactly. All right, now this one's a specific type. This is an isosceles one. So when we see an isosceles trapezoid, we put our base angles are congruent. So this is going to be 77. And then we think about our parallel lines cut by a transversal. So if we have 77, what does this angle have to be? Has to add to be 180, so 103. Same thing over here. This is also 103. See how it works? All right, so it says draw a trapezoid JKLM with JK. So we're going to start it going this way. So JK, so I'm going to put L and M here. So JK is parallel with LM. So see how I drew it? So match the pair of segments with the term that best describes them. So what are JK and and ML. What are these called in a trapezoid? Bases, so that was E. What about MJ and KL? Legs, right? So go through and see if we can match them. So ML and KL. Well, we did bases and we did legs. Look at our other choices. Are they base angles, consecutive sides, opposite angles, or diagonals? Consecutive sides, right? So B. What about angle K and angle M? So K and M. Opposite angles, good. So C. JL and KM, so JL, diagonals. And then the last one, angle L and M, they are base angles. So even if I didn't draw them on the bottom of my shape, those are still base angles, okay, because it's attached to the top base. All right, so show that trapezoid ABCD, or show that this is a trapezoid and by finding the slope of each of the sides. I need finding. All right, so A is 5, 0. B is 0, 5. C is 4, 7. And D is 7, 4. So all we have to do in order to show something's a trapezoid is we have to show exactly one pair of sides is parallel. That's it. Now if I had like Isosceles Trapezoid, we would need to show that those legs are congruent as well. Okay, but this just says a trapezoid. So it says find the slope of AB. So we're going to count the rise over run, so count down and over. We go down 5, we go over 5. So negative 5 over 5 is 1. For DC, we go down 3 and over 3. So negative 3 over 3 is, oh, sorry, not 1 above negative 1, right? So they're both negative 1. So these slopes are negative 1. And I think you can tell BC and AD do not have the same slope, right? So BC, we go up 1, 2. And we go over 1, 2, 3, 4. So it's 2 over 4, which is 1/2. And then in AD, we go up 4 and over 2. So that's 2. So we have exactly one pair of parallel sides. So that means it has to be a trapezoid then. Alright, so yesterday you guys watched the video on area. So do you guys remember what a mid-segment of a trapezoid is? What's a definition for that? What do you think? Yeah, Roman?
It's like the two bases
Uh-huh.
divided by 2.
Yep, it's the average of those two bases. So the segment that connects the midpoints of the legs, and it's the average of the two bases. Okay, so if I had that this was 32 and this was 48, let's say, then I could find the mid-segment by adding those two together. So I'd get, what, 80 when I add those together? And then dividing by 2, so I'd have 40 as the length of the mid-segment. Okay? So the mid-segment joins the midpoint, so those two are congruent, those two are congruent. The midpoint of each of the legs. Okay, and the mid-segment is important to us for a trapezoid. So if you watched that video yesterday, you saw that I did this little trick where I drew those vertical lines there and there. And I took this little triangle that was here, and it's like you cut it off. So imagine you have scissors and you cut it off and you put it right here. And same thing here, I cut off this little triangle and I put it down here. And what's created is you get a rectangle. So the rectangle has that width of 40 and it still has the same height it had before. Okay, so it's the area of a trapezoid is the mid-segment times the height. That's the best way to remember it. So our midsegment was our two bases added together, divided by 2, and then we multiply by the h. So if we take the midsegment divided by the height, get it. Do you guys remember that? All right. So it says carefully draw a non-isosceles trapezoid JKLM on the grid below. So use a ruler to measure each leg and find the midpoints, connect the midpoints of the legs to form the midsegment, measure the length of the midsegment in the following table. So let's try it. So you guys can go ahead and draw a picture. So draw a non-isosceles, so you can't have your legs congruent. So draw a trapezoid, and I'll get a ruler out. And we'll see what happens. All right, so we found the J, K, and ML, and when we added those together, so I had 138, so mine's a little bit bigger than yours because it's on the screen. And then I found half of it and found this measurement, and it was 69 millimeters, and that's half of that JK plus ML, so it worked out. Okay? All right, so the midsegment theorem for trapezoid says the midsegment of a trapezoid is parallel to each base, and its length is half the sum of the lengths of the bases. So it's the average. Okay. So looking at some pictures, we have some kind of easy problems with these. So it says find the length of the midsegment. So can we all do this in our head? What's halfway between 14 and 16? 15. So that's the easiest way to find that average in that case. You could add them together though and divide by 2 if you want to. So about this next one. So 11 added to x divided by 2 must equal 8. So do you guys remember when we did the midpoint formula and I taught you a trick for midpoint? So if I had like 1, 4, and I went through the midpoint, 7, -2, and then I wanted to find the next endpoint, b. Do you guys remember how we did that? We said, okay, I'm going to add 6. I'm going to add 6 again and get 13. And I subtracted 6, and I'm going to subtract 6 again and get -8. Do you guys remember doing that? You can also do that with this kind of stuff. So how did I go from 11 to 8? What did I do? I subtracted 3. So in order to go from 8 to x, I'm going to subtract 3 as well. So what does x have to be? 5. So you could set it up the way I did with the 11 added to x divided by 2 must equal 8. But you'll get the same thing because you'll multiply that 2 over and you'll get 16. So then x has to be 5 then. Okay, so sometimes you can kind of use logic to solve these without writing out an equation. All right, so a kite. So if you think about a kite shape, when you guys flew kites as kids, did you guys always fly kites? Yeah. I see people in West Park flying kites occasionally. So a kite shape has 2 consecutive sides congruent and then the other 2 consecutive sides congruent. So it's a quadrilateral that has exactly 2 pairs of consecutive congruent sides. So like these 2 are congruent, these 2 are congruent. So it's not quite a rhombus. A rhombus would have all 4 congruent. It's like extending a couple of those sides. Okay, so if a quadrilateral is a kite, then, so let's think about what's happening. What do we think is true about its diagonals? They're not the same length, it doesn't look like, right? But what's true about them? So when in doubt, I always draw a really tall, skinny one. What'd you guys say? Diagonals are, they're not congruent, they're perpendicular. Do you see that? They make 90 degrees. So if a quadrilateral is a kite, then its diagonals are perpendicular. So you could also abbreviate that with the upside down T. I always want to do a mathematical spelling bee during morning meetings sometimes. Have people spell perpendicular, lots of good words. All right, if a quadrilateral is a kite, then, so what else do we think is true? So let's think about some angles. So we definitely have the 90 degrees in the middle. Do we think that these angles are the same? Does it look like they're the same? It does. I don't think it does. I think one looks bigger than the other. Do you guys see that? So if you look in the real tall, skinny one, you can see that those angles aren't the same. All right, but what angles are the same? Does this one look the same as that one? think about folding it over on itself? Yeah. Does this angle look the same as this angle? Yeah. So if a quadrilateral is a kite, then exactly one pair of opposite angles are bisected. Okay, so it's not both pairs. It's not like a rhombus where both sets of opposite angles were bisected. It's just one pair. So either the top and the bottom or the right and left side, depending on how you've drawn it. Okay, so usually if you just draw a very exaggerated shape, you can come up with everything, and we'll talk about that throughout the day. So it says, what are the lengths of the sides of the kite? So let's start with this one. Do we see this right triangle? Are you guys experts at this now? Look at our right triangle and look at our measurements. We have 3 and we have 4. So we have 5, exactly. So 3, 4, 5, perfect. So same idea over here. We have 3 and we have 4. So we're going to have 5, which makes sense because the kite will have those opposite sides congruent. Now the other ones are a little bit trickier. So we have 2 and we have 3. There's not like a 2, 3, 4 right triangle. That doesn't work. Okay, so let's call this X for now. So we're going to square both sides, or both the short, like the legs, and add them together to be the hypotenuse squared, so Pythagorean theorem. So we get 4 plus 9 equals x squared. So x squared is equal to 13. So when I take the square root of both sides, I get x equals the square root of 13. I would leave it like that. So do you guys remember the PowerPoint I showed you the other day of math fails in real life? I would hate for you guys to be like, oh, 13. Oh, that's going to be, I don't know what square root of 13 is. 3.6, right? So my calculator is saying 3.605551275. And you're creating a bridge, which is in miles. And what if you you took the square root and you were like, oh, 3.6 miles. And then it's off by a certain number, 0.005 miles. That ends up being pretty significant, right? So we leave things as square roots if possible. All right, so find the values of the variables. So these opposite angles, those are congruent. Do we see that those are congruent? If we fold the shape over on itself, do they match up? Yeah, so we're going to say that 3x plus 5 equals 4x minus 30. So we get x equals, add the 30 over, 35. Okay, but we have other measurements. So we have this angle, and we have this angle, which I don't think that those are congruent to each other. These two would be, and these two would be, right? But they're not going to be congruent to each other because it's that kite shape, okay? So what can we do? So we got to figure out how to do this. So let's put the y over here because y could be there as well. And if we look at this triangle only, so let me kind of draw it down here. So we have y, we have 2y minus 20, and we have 4x minus 30. Well, x was 35. So if I do 4x minus 30, and I plug in x is 35, jeez. I get 140 minus 30, which is 110. So we have 110 degrees in here. So then how can we get y? So we say y plus 2y minus 20 plus 110 has to equal 180. So it's the triangle sum theorem. We just add up the angles to get a total of 180. So we have 3y plus 90 equals 180. We subtract our 90 over. So we get y equals 30. So y is 30 and x is 35. Okay, does this make sense? Do you guys get it? Okay, I think that's the end of that section.